Hello, Assalamu alaikum. My name is Ismita Bishash, section 67M, ID 242155055. And they are my team members, Mashrafi, Sadia, Rahib, and Nusrat. Today, our group is going to present on the topic of joint and no school. I would like to talk about the first part of our presentation. Change the slide, please. Here the presentation outline of where I would like to talk the first part, and the other four part will talk my team members. Next slide, please. This slide is about bringing tables together using join. Join is an important feature of SQL. It combines data from two or more tables. Combine rows means join brings related into one result, and then linked by a common column means tables are connected using a common column, usually a foreign key. Code to RDBMS means join is essential for getting related from data from different tables. Next slide, please. And on the second slide, now I would like to talk why we need join in SQL. First, in normalization, it basically divides data into related tables and reduces duplication. Then reconstruct information. Join brings data from different tables together. Then have no duplication. Data is stored once and reduced when needed. Then last one, a real world scale. Join is useful for large connected databases. So I think join keeps data organized and easy to manage. Next slide, please. Here is the basic syntax and structure. Where you can see the syntax of join. There are select columns, which in columns we basically shows the data we want. Then we have from, where specifies the first table, and then join, that connects another table. Then on matches the common column, common column. Then next slide, please. Here is with an example of join, basic join. Here you can see students and course column is connected to join, and here's the first output where student ID and student name, then course ID, student name, and course name. And when we create table, insert values different, two different, then we can join, and we can get a student name and course name which is common in two tables as also. Please next slide. And last page of our slide, of my slide, advantages of join. Combines data. It basically brings related data from different tables together. Then reduces duplication. It avoids storing the same data repeatedly. Then it helps keep data consistent and correct. Then less repeated data means less storage in needed. Then easy data access. So join makes data management simple. Now that's all for me today. Thank you everyone for listening my presentation carefully. Now I would like to hand over the next part of my next presentator. Thank you everyone.
Hello everyone, I'm Sadia Islam. My ID is 242158084. My previous team member has introduced you with joins. I'm going to talk about several types of joins, including inner join, left join, right join, full outer join, natural join, equi-join, and so on. Each type of join works differently depending on what data we want to retrieve. For example, an inner join returns only matching records, while an outer join can also include records that do not have a match. In the next slide, I will explain some of the most commonly used joins with examples. Next slide. Now let's look at inner join. An inner join is one of the most commonly used joins in SQL. It returns only the records that have matching values in both tables. In this example, we have a menu items table and an orders table. Both tables have an item ID column, so we can use this column to join them. The query matches the item ID from the orders table with the item ID from the menu items table. As a result, we get information such as the order ID, customer name, item name, and price. So, in simple words, inner join gives us only the common data between two tables. Next slide. Next, we have left outer join, right outer join, and full outer join. A left outer join returns all records from the left table along with the matching records from the right table. If there is no match, the right side values will be empty or null. A right join works in the opposite way. It returns all records from the right table and the matching records from the left table. Finally, a full outer join. It returns all records from both tables. It includes both matching and non-matching records. So the main difference is which tables unmatched records we want to keep. Next slide. Finally, let's discuss cross join and natural join. A cross join creates every possible combination of rows from two tables. For example, if one table has two rows and another table has two rows, the result will contain four combinations. This is also called a Cartesian product, a natural join. On the other hand, automatically joins two tables using columns that have the same name. We do not need to specify on an on condition. However, we should be careful with natural join because columns with the same name may not always represent the same information. To conclude, different joins help us combine tables in different ways depending on the data we need. Thank you.
Hi everyone, I am Safwan Ahmad Rahib. My ID is 242150997. Today I will be explaining NoSQL. Next slide. So, what exactly is NoSQL? The biggest difference is that NoSQLs offer flexible data models. You do not need to set up a rigid scheme beforehand. It easily accommodates different formats like documents, graph, and key value. It built it is built specifically to handle unstructured data. Next slide. Key value stores. The fast and simplest type of NoSQL is the key value stores. You can think of it as a giant fast dictionary. Every single item is stored in the table and we use key to find the value. Because the structure is so simple, lookups by key is ultra fast, giving us big of one retrieval time. Next slide. Document databases. Next, we have document databases. These database use nested structure. That means the documents can be contained with key value pairs, key array pairs, or even other nested documents, typically stored as JSON or BSON. Next. Wide column stores. Finally, let's discuss the wide column stores. Traditionally, this database stores data in a row, but traditionally, database stores data in a row, but wide column row stores data in a flip concept. It group columns of data together. As you can see in the diagram, this is a very powerful shift of analysis workloads. This is for heavy analyzing. Thank you.
Assalamu alaikum everyone. My name is Mashraf Ibn. My ID is 242150776. So my teammate already told about the importance of SQL and basically the NoSQL part mostly. So now I'm going to talk about the graph databases first. So what they store? They basically store the nodes, edges, and the properties. The nodes are basically they can be customers, they can be persons, and many things. And the edges are basically the relationships between them, and the properties are basically the additional informations stored between them. So why not SQL? So SQL is basically the core reason why we don't use SQL most of the times is basically the join. The self joins traverse in relationships. The self join actually makes a lot of tables and tables to tables and tables and many tables, and that's why the self join creates a lot of tables with joins between them, and it actually computes a lot of time. And the constant time is the dataset size. The dataset size is basically a large amount of data which computes and it takes time. So imagine someone is trying to load something into, it can be a social network or anything. So if it takes 10 to 20 seconds, the user base already is annoyed by that thing. So the time constant is really a big matter about SQL. So, why NoSQL? So, there are few points which can be marked. The first one is the no joint penalties. So, my teammate Rahib already told the key value pairs. So, here we can see the no join penalties or the denormalization is basically the data is nested inside one document. Let's think about a JSON data. JSON data is basically the key value pairs. So you are storing the key value pairs and it is only storing in one document. So you can just easily recover data from there. So the next thing is the in-memory optimization. So we can actually use the RAM inside our system or server, and that's why it stays cached and the cached data comes frequently. The third point is seamless horizontal scaling. So NoSQL actually uses many servers. On the other hand, the SQL uses only one server, and that's why the SQL is actually the pricier one and the NoSQL is actually the cheaper one and can be better sometimes. And coming to the fourth point, and it is low overhead writes. It is basically the document flexibility and nothing else. It basically waits or awaits for the disk confirmation. The next is the SQL versus NoSQL, the main difference that I'm going to talk about. So the first one is the data model. It is a structured tables for SQL and with rows and columns. So we have already done MySQL and we have seen we have to create a lot of tables with rows and columns. But on the other hand, the NoSQL does not have any table, and that is why it is non-relational database. So this is basically the document based or maybe graph based or maybe key value or maybe columns. Only columns. The second one is the schema. The schema in SQL is basically enforced or defined upfront. On the other hand, the NoSQL is basically flexible because we are keeping it in a one document only. The third point is the most important point of this thing. So that is basically the transactions. And this actually decides if we are going to use the SQL part or the NoSQL. So just long story short, if you're working in a big tech company, the big tech companies focus on the SQL or the NoSQL, and it depends on the project outcome. So if it is a project, imagine it is a project of a bank. So if it is a bank project, then you should use the SQL. Why? So now here we can see the SQL gives us full ACID guarantees because it gives us the triggers, the procedures, the everything we need to know to prevent some for example, if you want to prevent a negative balance or prevent insufficient balance, then in the SQL part you can do it very easily and it is more secured. That doesn't mean NoSQL is not secured, it is also secured, but when you want to implement the same thing in the NoSQL part, it can be trickier. On the other hand, when should you use NoSQL? The NoSQL is when you don't need a lot of things to work behind the project. For example, I already gave you the example of the prevention of the negative balance. So if you want to just escape those things and you just want to follow on the APIs, then you can just use the NoSQL and it will be easier for shorter projects. On the other hand, if you are using SQL, there can be many tables and etc. So if you want to change, you have to change a lot of things, the tables first and then the queries. But on the NoSQL part, you just need to change with the queries. So the fourth point is the scaling. It can be vertical, and for the NoSQL part, it is horizontal. I already discussed it. When we are talking about server, the SQL is actually the bigger machine. You need to provide a lot of money on that. But on the other hand, the NoSQL, it can contain many servers like 1 or 10 or 50, and it is actually the more machines, and you're paying actually less money on those machines than keeping a one machine which is bigger and keeping a lot of price there. On the other hand, we have the query strength. The query strength in SQL is actually the complex join and aggregation. And on the NoSQL part, it is basically scaling, speed, and flexibility, which is better. And most of the cases, it's basically the speed thing you need for the project. So that's it. So on the next hand, the join challenge in NoSQL. So the traditional, I already said, the traditional SQL actually uses the many join parts. So it can be multiple tables. But on the other hand, the NoSQL does not use join. It has join support. It doesn't have most of the databases doesn't have the join support for NoSQL. But currently in this state, for example, MongoDB, it has a native support for now. So let's talk about the SQL for the join here. We can see we have a code here. The select, we are selecting orders from the we are selecting some all every columns from the orders, and we are joining the customers and also joining the products. It looks very easy, right? Yes, it is easy. But if we want to talk about the NoSQL part here, it can be trickier. How? In the NoSQL part, you have to bring the data from somewhere. So we have already seen the MySQL part, we are only connecting the orders, the customers, and products directly. But on the NoSQL part, you have to connect these from the front end or directly from the back end. From the front end, you have to take one client, one API, and you have to push those data to other APIs, and then you can get it from the backend. So it is basically a complex thing to do it in the NoSQL part, but it is very easier in the SQL part. So as I said, it depends completely on the project which you are going to use. So the join patterns in NoSQL, I already talked about it a little bit. So the client-side joins, it is basically the API calling from the front end. Yeah, if you want to call the customers, you can fetch it from the front end, and you can directly get it on the back end. And denormalization is basically one parent document, and you are just messing with those parent documents. And third number is the materialized views. It basically pre-compute and stores. So as I said, the modern join support, most of the databases doesn't support join, but some databases do, like MongoDB. It is added in the version 3.2, some Couchbase and Elasticsearch. So that's it from my side. Thank you very much. I would like to call my next teammate, which is Nusrat Jahan. Please. Thank you.
Assalamu alaikum. I'm Nusrat Jahan. My ID is 2421504. I'll be presenting the conclusion and decision making part of our topic. So let's move to the final part of our presentation. After discussing both relational databases and NoSQL databases, we can see that there is no single solution that is best for every situation. The choice mainly depends on the type of application, the workload, the data relationships, and the consistency requirements. In the next few slides, I will explain when we should choose relational databases and when NoSQL is more suitable and how we can make the decision. Here, we can see the fundamental trade-off between relational databases and NoSQL. Relational databases, especially when we need joins, are strong in data consistency, normalization, data integrity, and we need complex queries across those entities. A relational database is usually a very good choice. On the next hand, NoSQL focuses more on horizontal scalability, high throughput, and relational databases, especially when we need joins, are strong in data consistency, normalization, data integrity, and complex relationships. If an application has many connected entities and we need complex queries across those entities, a relational database is usually a very good choice. On the other hand, NoSQL focuses more on horizontal stability, high throughput, and flexible data model. So if we have a huge amount of data and need to distribute it across many servers, NoSQL can be more suitable. The most important point here is there is no universal winner. The right choice depends on our specific requirements. Next slide. Now let's look at when we should choose a relational databases with joins. First situation is complex relationships. If our data has many relationships between different entities and we need flexible queries, relational databases are very useful. Second one is compliance is crucial. For example, in financial transaction, booking systems, or inventory management, we cannot afford inconsistent data. Another situation is ad hoc queries. If we don't know exactly what queries we will need in the future, relational databases give us more flexibility. We should also choose relational databases when data integrity is very important because foreign keys and other database constraints can enforce relationships at the basement level. Finally, for moderate scale database sets, if the data can comfortably run on a powerful single server, a relational database may be simpler and more practical. So overall, relational databases are a strong choice when relationships, consistency, integrity, and flexible queries are important. Next slide. Now let's look at the other side. When should we choose NoSQL? First case is massive scale. If our system needs to distribute data across thousands of nodes, NoSQL databases can provide excellent horizontal stability. The second is the high throughput. For applications that need millions of reads or writes per second, NoSQL can be a suitable option, especially when eventual consistency is acceptable. Another important factor is known as the access patterns. If we already know how our application will access the data, we can design the NoSQL data model especially around those access patterns. NoSQL is usually useful when we need a flexible schema, especially when data structures changes frequently or different documents have different structures. And finally, NoSQL can be useful for real-time analytics, data series, data, then event streams. So in simple words, NoSQL is a good choice when we need massive scale, high throughput, flexible data structures, and predictable access patterns. Next slide. However, in world applications, we don't always have to choose only one technology. We can also use hybrid approaches. For example, we can use a relational database for transaction data and a NoSQL database for analytics or caching. Another approach is NewSQL, which tries to combine the strong consistency and SQL capacities of relational databases with the stability of distributed systems. We can also use denormalization in relational databases to reduce the need for expensive join operations. Another option is application level joins, where data is fetched separately from different sources and combined within the application. And finally, event sourcing can be useful when we need an audit trail and event-based structure. The important lesson is that modern database architecture is not always about choosing one side. Sometimes combining different approaches gives us the best solution. Next slide. Finally, this slide gives us a simple decision framework. First, we can start with a relational database by default unless there is a specific reason not to. Second, we could measure before migrating. Instead of assuming that NoSQL will automatically be faster, we should first look at our actual query patterns, workload, and stability requirements. Third, we need to define our SLA and consistency requirements. We should ask ourselves how much consistency do we need, how much ability do we need, or what level of performance is required. And finally, we should iterate over time. As our application grows, our workload and requirements may change. So our database architecture can also evolve. The key idea is used based on evidence and not as assumptions. Next slide. Okay. So conclude, joins, and NoSQL are not competitors where there is only always better than others. NoSQL is excellent for massive scalability, high throughput. That's it. And in many real systems, a hybrid approach can prove the best balance. Therefore, the best database is not necessarily the most popular one. Thank you everyone for your time and attention.